In this video we will study about traditional programs versus machine learning (ML) programs, with example of temperature conversions program, with traditional program approach, ML program approach. We will study about traditional programs versus machine learning (ML) programs. Traditional programs versus machine learning (ML) programs. Traditional programs and machine learning (ML) programs are two different approaches to programming, each with their own advantages and disadvantages. Here are some key differences between traditional programs and ML programs. Traditional programs are rule-based, where a programmer writes a set of instructions or rules for the program to follow. Traditional programs are deterministic, meaning that the output of the program is determined by the input and the rules provided by the programmer. Traditional programs require a programmer to specify the rules and logic for handling different scenarios. Traditional programs are good for tasks that have well-defined rules and logic, and where the input data is consistent. ML programs are data-driven, where the program learns patterns and relationships in data to make predictions or decisions. ML programs are probabilistic, meaning that the output of the program is based on the probability of a certain outcome given the input data. ML programs use statistical algorithms to learn from data and improve their accuracy over time. ML programs are good for tasks where there is a large amount of data and patterns are difficult for a human programmer to identify. In a machine learning (ML) program, a dataset is a collection of examples or instances that the program uses to learn patterns and relationships. The dataset consists of input features and output labels, where the input features are the data points that are used to make predictions or decisions, and the output labels are the true values or labels for each input data point. Training dataset. This is the dataset used to train the ML model. The training dataset consists of input features and output labels, and the model uses this data to learn patterns and relationships. The goal of training is to minimize the error or loss between the predicted output and the true output labels. Validation dataset. This is a subset of the training dataset that is used to evaluate the performance of the model during training. The validation dataset is used to tune the model's hyperparameters, parameters that are not learned from the data, and to prevent overfitting, when the model is too complex and fits the training data too closely, but performs poorly on new data. Test dataset. This is a dataset that is used to evaluate the performance of the trained model on new, unseen data. The test dataset is used to measure the model's generalization performance, or how well it performs on data that it has not seen before. Unlabeled dataset. This is a dataset that does not have output labels, and is used for unsupervised learning tasks such as clustering or anomaly detection. The goal of unsupervised learning is to find patterns or structure in the input data. Aspect traditional programming machine learning. Input predefined rules or user input data set containing examples of inputs and desired outputs, processing explicit coding based on the predefined rules. Algorithms automatically learn from data and improve over time. output directly determined by the rules in the program predictions based on learned patterns and relationships in the data. Adaptability must be manually updated to reflect changes in rules, or data can adapt and improve automatically with interpretability. In traditional programming, rules and decision-making processes are transparent. In machine learning, can be more opaque and difficult to interpret due to the complexity of the learning algorithms. Accuracy limited to the accuracy of predefined rules and human input can potentially achieve higher accuracy as the machine learning algorithms learn from more data. Expertise requires expertise in programming, and knowledge of the domain requires expertise in both programming and machine learning, as well as knowledge of the domain. Speed generally faster than machine learning for smaller data sets, slower initially for larger data sets, but can improve with more data and computing power. Example: temperature conversions, temperature units conversion from Fahrenheit to Celsius. Temperature units conversion from Fahrenheit to Celsius, with traditional program approach, ML program approach. Traditional program approach could be a program that converts temperature units from Fahrenheit to Celsius. The programmer would define a formula for converting Fahrenheit to Celsius and write code to input the temperature in Fahrenheit and output the corresponding temperature in Celsius. In contrast, an ML program approach for the same task could use a dataset of labeled temperatures in Fahrenheit and their corresponding temperatures in Celsius. The program would learn the relationship between Fahrenheit and Celsius temperatures, and use this relationship to predict the Celsius temperature for a new input in Fahrenheit. Y equals F, X, Y is output, F is prediction function, X is feature. The advantage of using an ML program in this case is that it can handle more complex temperature conversions, such as converting from Celsius to Fahrenheit, or converting temperature readings from a nonlinear temperature sensor. A traditional program may not be as flexible in handling these scenarios. Machine learning, ML, programs are a type of software that can learn from data and make predictions or decisions based on that learning. They use algorithms and statistical models to analyze and learn patterns from data, and can be used for a wide range of applications, such as image and speech recognition, natural language processing, fraud detection, recommendation systems, and many more. ML programs also have some limitations and challenges. They require large amounts of high-quality data to train effectively, and can be sensitive to biases in the data. They can also be difficult to interpret and explain, especially for complex models such as deep neural networks.
Thank you for watching this video.